Okay, the last problem that I have today, and if you've tuned me out because the last three problems were all pretty much the same difficulty. This is also, but it has one extra little detail in it that people do wrong all the time because right around this problem they quit listening to me. So I'm going to give you that warning up front. So if you listen to me, you're less likely to make the mistakes people make in these problems. All right? If you do listen to me, maybe you still will, but you're less likely. Quadratic equation equals, right? So I'm going to move the 9 over there because that's obviously a positive x squared term. So 3x squared is fine where it's at, 6x is fine where it's at, both staying what sign they were, positive and negative. 9's moving to the left becomes negative 9 equals 0. Now this is a quadratic trinomial. It's very much like problems 1 and 3 were. All right, trinomial, 3 terms. I don't want a number in front of x squared in a quadratic trinomial, so I'm going to factor out a 3. So if I take a 3 out, I'm going to be left with x squared minus 2x minus 3 is equal to 0. That is legal, that's the greatest common factor, and that is always the first step of factoring. This just happened to be the first one that had one today. Okay, but it should always be in the back of your mind that a greatest common factor could occur, so hopefully when it's there it's pretty obvious and you can see, oh yeah, there's a greatest common factor, better take it out. But if it's a trinomial, you don't want anything but 1x squared right now because I haven't shown you how to factor anything else. When we get to the uglier ones with numbers in front that don't factor out, those are harder to do. We'll deal with those somewhere in the early 100s on the lessons. At this point, my quadratic trinomial is right here. And I want to factor that completely. So I'm looking for factors of negative 3 whose sum is negative 2. So 1 and negative 3 do the trick. So, looking at this factored form, 3 is still 3. The factored form of the quadratic trinomial is x plus 1 times x minus 3. Gets me to here. Now, how many factors are there? 3. Okay, so let's take a look at the 3 factors. My factors are 3, x plus 1, and x minus 3. Alright, and what the zero product property says, if I have things being multiplied together, that one of the things has to equal 0, right? It doesn't say all 3 have to equal 0, just one of them has to equal 0. So if I set each thing equal to 0 individually, so 3 equals 0. X plus 1 equals 0. X minus 3 equals 0. That's what the zero product property specifically states. When you have that structure, product equals 0, each factor individually equals 0. I'm going to start with the green one. If x minus 3 equals 0, I'm going to move the 3 over, it becomes positive, right? That gets me x is equal to positive 3. If I solve this one, I move the 1 over, subtract 1, it gets me x equals negative 1. Okay. Look at this statement. What's missing?
X.
X is missing. If there's no x, there's no answer. Does 3 equal 0?
No.
That gets me nothing. Only factors that contain a variable create an answer. Okay? What's the most number of answers? Bless you. What's the most number of answers possible in this problem?
2.
2, and we know that because x squared, right? So 3 and negative 1 are 2 answers. Once we found that there aren't any more, hundreds of people in the years I've taught want to put a 0 as an answer also because 3 equals 0. I don't know how to handle that. Let's just put a 0 down. Right? That'd make 3 answers when the maximum number of answers is 2. So know the maximum number of answers, see that you got the maximum number of answers, and don't try and create something out of nothing. 3 equals 0 is false, creates no answer. X's create answers, numbers create either true or false. All right?